So yesterday we solved equations where we could make the bases the same. So today we're going to solve equations where we can't make the base the same. Okay. So whoops, I need a pen. Yep, I need a pen. Thank you. Okay. So solving exponential functions. Functions, let's say, without common bases. So I guess we could say using logs. That's the big thing. So when you can't use that idea of getting the bases the same to solve for the logs, or to solve the exponential function, you have to use the logs. So as simple as this. What's a good example here? I've got, well, maybe we shouldn't do that. Yeah, we'll do one first here. So 3 to the x, and you guys won't recognize this because we'll do the exponent, the rules right after I do this example, equals 4. Okay, so this is a perfect example where we can't make the 4 and the 3 have a similar base, can we? So that's, like I said yesterday, why the idea of logs is introduced, so you can solve things that aren't really possible. Okay, just so you've got a complete example in here, we'll say the log of 3 to the x equals the log of 4. So you're going to find out soon that I'll say take the log of both sides. That'll kind of be one of the steps. Take the log of both sides. And then you're going to learn a rule here in 2 minutes where this 3 to the x, we actually call that, what is it back there? I don't even have it back there. It's the power rule, right? It's sort of like saying the power of power rule in grade 9. When we had the power of power rule, what did we do with our exponents? We multiplied them. And remember, a log is an exponent, right? And it has an exponent of x, so I can change that into x times the log of 3, right? Because the idea of a log being an exponent, well, an exponent to another exponent says you just multiply your exponents. So there it is. And the log of 4. So now if I wanted to solve for x, what would I do? Divide by log 3. Good. So you'll see all that in the rules right away. So we're going to divide by the log of 3. That cancels. X equals, I throw log 4 divided by log 3 in my calculator, and you should get 1.262. Okay? There's the answer. Okay, so make sure you got your calculators out because we're going to use them today quite a bit. And you want to know, did we get 1.262? Perfect. Okay. Everybody's okay with that right now? Because we're going to write down all the log rules right away. Good? Okay, so I'm going to go to a new page. All right. So, log rules. Some of them we just pick up later. We're going to do 4 right now. So 1, we already did it, the power law says this. The log of base A, okay, and let's put a P here, and let's say it's to the capital M. So just like that 3x that we had there, well, this can be turned into M times the log base A of P. From that same idea in grade 9, the power of a power rule, remembering that a log is an exponent. So it's like we're saying an exponent raised to the other exponent m, we can just multiply them. Go ahead. Power law? Yeah. Can't believe you can't read my writing. 2. Now, this one, again, multiplication law. Multiplication law. Okay. So now this one, log base A of m times n equals. So let's think about this. When we were multiplying common bases with exponents, what did we do with our exponents? We added them. So we're multiplying our exponents, right, with common bases. So I can say the log base A of m plus the log of base A of n. Maybe I'll block these off here just so we keep them separate. So again, when you multiply within the log, you can break that up or expand it, they would say, expand it into addition of two logs. And it might be three things you could if there was three things inside that, you could break it up into three additions. Go ahead. They do. That's the thing. Remember, if you're multiplying, look at this, m and n, multiplying with a common base, what can you do with your exponents? Add them. You see how that works? Let's do, obviously, what comes after multiplication then. Whoops. The division law. So the same idea, when we're dividing with common bases, you can subtract your exponents, right? So the log base A of m subtract the log of base A of n. It is, but you're going to see that when we're not talking about logs with different bases, we're talking about exponential functions with different bases, right? And when we change them over into logs, that gives them the common base, right? As you looked on that last example we did, when we took the log of both sides, it automatically had the same base. What was the base? What was the base on the first example? That 3x equals 4. What's the base if it's not written there? 10. So it created a common base. Okay? So now 4. This one here, I might even do just I might not prove it today, but you'll see the proof of it as we go along. It's called the change of base rule, or change of base law, whatever. And this is one where when you get logs, like this, a log of base, what did I put here in my notes, of A of m, and you don't like that base, because I'll be honest with you, what we're going to get accustomed to using is a base what? 10. If it's got some other number other than 10, you can't put it into your calculator. You can't use your calculator. So in order to use a calculator, you got to somehow get it so that it is base 10. So that's what the change of base law is used for. So this is equal to saying the log of m over the log of A. And you'll notice that the base is now 10. Okay? When you do that change of base law. Like I said, you'll see the proof for that soon. And it's super easy. All right. You got that written down? Let's do the next one. Now, let's get into some examples here. We've done one example, the 3 to the x. Let's do this one. 2 times 5 to the x plus 2 equals 7. So it looks so similar to the last stuff we did, right? Except what can't we do with our bases? You can't make them common. You can't make a 5 into some common base as a 7, right? So you've got to use logs. So we got to think about our rules that we kind of did before. So isolating the exponential function, right? That was one of the first things we talked about. So what do I got to get rid of here? The 2. So I got to isolate by getting rid of that 2 first. Now I don't have to it just makes life a lot easier. So isolate the exponential function as much as you can. So then you're stuck with 5 to the x plus 2 equals 7 over 2. 3.5, ugh. Okay, stick with the fractions. Now, if I was writing steps, step 1 is going to be take the log of both sides. So log of 5 to the x plus 2 equals 7 over 2. And it's really quite this simple. If my variable is outside of the log, and you'll see on the next step what I'm talking about, when the variable is outside the log, I can just isolate x. Okay? That's your goals, isolate x. Later, we're going to do it where the variable is inside the log. When that happens, you kind of have to work yourself till you have common bases, and then you turn it into exponential functions and solve that way. Okay? But right now, sorry guys, I didn't take the log of that. That one there, sorry. Let's go with the log of 7 halves. Too busy yapping. So, yeah, we're just taking the log of both sides. That's your first step. Once you do that, now you can bust into those rules that we just did. So now I want to get so that like the variable isn't an exponent anymore. So I can use the power rule, and it says this: x plus 2 times the log of 5 equals the log of 7 halves. Right? So now it's no longer an exponent, right? It's a coefficient. So if I multiply the log 5 into this bracket, yeah, you could divide the log 5 out, yeah. I'm just going to keep going this way, though. That would work fine as well, and then minus the 2, yeah, totally. So x log 5 plus 2 log 5 equals the log of 7 halves. As long as you're not breaking any rules there, you can solve for x however you want. Okay? I think this is more the common way to see it, but I don't know. So now I just got to isolate x. Like I said, if the x is outside the log, like you notice it's not in the log, like log 5, it's not with that. It's in front, it's not in it. You just isolate x, just like you would grade 9 solving linear relations. Okay? So I'm going to minus the 2 log 5. Minus the 2 log 5. That cancels this guy out. And now I've got x log 5 equals log of 7 halves minus 2 log 5, like so. What would you do with log 5 now? Divide it out. Out of both sides. So, x equals. So let's get our calculators out because we got to know how to do this. Pump her into your calculator. Log of 7 halves. 7 divided by 2, log, or log 7 divided by 2. It's up to you and your type of calculator you've got. So yeah. And then subtract 2 times the log of 5. And then I would always hit equals right there. And then divide by the log of 5. And you should get negative 1.222. Yeah? And always to 3 decimal places, correct? Yeah, that's it. That's about as hard as it gets for that one. Okay? Now, you'll notice here, I could also change this. If I didn't want to do the 7 divided by 2, what could I have said there? Log of 7 subtract the log of 2. Why? It's the dividing of the log, right? And your division rule says you can change that to a subtraction question if you didn't want to do it. You don't have to for this. There's no reason to do more work. No, it doesn't. Go ahead, try it. Go log of 7. Subtract log of 2. Subtract 2 times the log of 5 equals divide by the log of 5. Okay? Next page. What do we got for another example here? Let's write some steps out real quick. Steps. 1. Take the log of both sides. Take the log of both sides. 2. I guess simplify however you want to do that. And 3, isolate x, or isolate the variable. There's not much more to it than that. Okay? Nope, doesn't matter what mode. That's right. Yeah. Let's see if we can squeeze an example in here. 2/5 to the x minus 3 equals 1/3. Now, once you do this enough, right away, if I take the log of both sides, that's fine. Where's that x minus 3 going to go? In the front. So I wouldn't say do it right away because you're just learning this stuff. But a lot of people will eventually get to that point where it's not a big deal. And here it's still kind of a big deal that you have to show that, take the log of both sides, because I think you'll lose actually half a mark when it comes time if you don't show that first step. But realistically, this step here is almost just busy work. Right? My exponential function is already isolated, so I can just take the log of both sides. I guess maybe step 1 could have said isolate the exponential function. Right? But whatever. So now the power law. This is the one where I was saying most people would even start with this step. So the log of 2/5 equals the log of 1/3. Again, this log of 2/5 and log of 1/3, could I change that to show something else? Yeah, I could say the log of 2, subtract the log of 5. I could say the log of 1, subtract the log of 3. I could do all that stuff, but doesn't save us any time. Now, let's go the other way. So instead of multiplying into the brackets, let's divide by log of 2/5. So instead of going through the process of multiplying it in, get rid of it right away. So now I've got, I'll put it up here, x minus 3 equals the log of 1/3 divided by